All right, good evening. It is 5 o'clock, February the 12th, 2025. I want to welcome everybody this evening. That's the ones that are watching these recordings. You're doing it right, man. If you're watching these recordings, I am telling you stuff you need to know to do well on the tests and also on the AP exam when it comes up here in Maine. So I'm going to go ahead and jump right into it tonight. I'm not going to spend any time jibber jabbing here. I'm going to jump into it. And then, as always, I'm turning off my video so that I don't pull down your bandwidth nor my bandwidth here. And I'm going to go ahead and share my screen with what we're going to do tonight. I think I am. There we go. Now I am. All right, so we're moving forward. I know I'm a little bit ahead of most of you. I think there's one person that's actually keeping up with me as far as the stuff is going. But when we get to the later unions, particularly when we get to Perfect Competition Monopoly, which is coming up the next two couple of units, those are going to take 2 to 3 weeks to do those. And so I want to make sure that I've covered them so that when you go to actually work on those units, you've got this resource for you here. Again, don't forget my class notes are also posted on the shared resources section, and there's a link to all sorts of videos that you can watch. So don't forget that stuff's out there too. And of course, always reach out to me if you have any questions at all. So tonight, what we're going to do is we're going to do cost curves. I'm going to walk you through all the cost curves that are in this course. I introduced this last week, and I went through and I talked about, one of the things you got to look at is you got to look at, economic cost. Economic cost is opportunity cost. And I made a big deal about how accountants don't consider opportunity cost. Accountants only consider what we call explicit costs or costs that you're paying. Whoops, how did that happen? Okay, well, go away, whatever that is. Give me a sec here. There it went. Okay. Accountants only consider explicit costs or costs that you pay others, things like your rent or paying for the inputs that you're using or paying for the labor, anything like that. Those you're paying to others. But economists worry about this thing called an implicit cost. An implicit cost is your internal cost. What are you giving up to run that business? If I am open up Pat McKee's Pizza Palace, and I have to give up teaching, right? And so I'm giving up the time to do Pat McKee's Pizza Palace, yes, but I'm giving up the money I could have earned as a teacher. And what if I took $100,000 out of my bank account and invested it in my business? Well, that $100,000 could actually be somewhere else earning interest. And by putting in Pat McKee's Pizza Palace, that is an opportunity cost. So accountants don't take into consideration where economists do. And what we come up with is we come up with an economic profit. And if you have a positive number at the end of this, so the example I've got up here, we actually have zero economic profit. We have zero economic profit because we're doing just as well here as we could in next best alternative because we're bringing in $200,000 in revenue, total revenue, which is price times quantity, selling X number of pizzas at X price. I'm paying externally $100,000 to run the business, and then I had $100,000 implicit cost. That could be again money that I used in my business that could have been earning interest in the bank account, the interest I could have earned in the bank account, plus my cost of quitting my other job. Right. So if this were the case, the accountant would be say, great, you're over here, you earned $100,000. But I'm thinking, yeah, but I made $100,000 in my old business. So really, I'm no better off. And that's what zero economic profit is. Where this one here, you can see that we're earning an economic profit because we lowered our explicit costs. We still have the same opportunity cost here, but we're earning what we call a $10,000 economic profit. Again, the accountant is saying, great, you made $110,000. So there's a big difference between the accountants and the economists when it comes into account profits, right? I then went in and talk about the difference between short run and long run. In the short run, you have fixed resources and you have variable resources. In the long run, everything is variable. Okay. In the long run, you can completely wipe out a factory and build a whole new factory if you need to. There's not a time period. We can't say 2 weeks or 2 months or 2 years is fixed or variable. You have to know if you have no fixed resources. In other words, if you can start all over again then that's long run. Okay, and that's basically the idea of what we've got there. So here we go. Let's get into what I plan on doing tonight. I'm getting these cost curves. So in order to introduce the cost curves correctly, we need to start with this thing called the law of diminishing marginal returns. Right. If you remember earlier in the semester, very early in the semester, we learned about something called the law of diminishing marginal utility. And the law of diminishing marginal utility said that as you consume more of any product, your marginal utility diminishes or goes down. Okay, your utility is satisfaction. And I said this holds true for everything. Everything you get diminishing marginal utility. The more of something you do or use or eat or anything, the less additional satisfaction you get. Now, again, there's a time period for this. If you go to an all-you-can-eat pizza place and you're starting to eat your pizza, by about the third or fourth piece, you're not getting as much satisfaction as the previous piece. That's diminishing marginal utility, right? Fast forward 3 weeks later, you walk in there and eat that first piece of pizza, you're like, oh man, this is good, right? You kind of rebound back, but then as you eat the second and the third and fourth, you get diminishing marginal utility again, right? And so that's the concept we learned earlier in the semester. Okay, what we're going to learn now is what's called the law of diminishing marginal returns. And this one, it's the same principle, but we're talking about adding variable resources to a fixed resource that you start to get diminishing returns. And let me show you how I've always taught this. Okay, so right up the street from my home school, there's a Brewster's Ice Cream. Okay, just picture a local ice cream parlor or something like that that's up the street from you or somewhere around where you live, right? And our Brewster's Ice Cream, it has a building, okay, and it has 2 windows right there. And inside there, you've got a worker. All right. And let's say in an hour, that worker can sell, you have one worker, that worker can sell 17 ice creams in an hour. In other words, he can help 17 customers in an hour. We don't know, let's just say everybody orders a single ice cream, a single scoop of ice cream. Okay. He can order 17, sell 17 ice creams in an hour out of that one window. So his additional production is actually 17. We're going to call that the marginal product, marginal additional product production. Okay, so his additional production is 17 ice creams. He sells 17 more ice creams, right? And let's suppose that we always got to assume that we have an infinite number of customers sitting out here wanting to buy ice cream. Okay, obviously if nobody shows up to buy ice cream, then he can't sell any. But we ignore that. We just assume that we've got this infinite supply of customers waiting to buy the ice cream. So this businessman says, hey, you know what? I think I'm going to go ahead and order. I'm going to hire another worker. So he comes in and he he hires another worker. And notice here, you've got your first window here. And in this case, the red worker is working at the first window. And then the green worker is working at the second window here. When we hire the second worker, we now have 2 workers. So if the first worker provided 17 ice creams, how many ice creams do you think the second worker could sell an hour? And we assume the workers are the same. They're identical workers. One's not better than the other. One's not more experienced. One's not faster, taller, or anything like that. Again, not a realistic assumption because not all workers are the same. Some workers are better than others. But what most people would do is most people would look at this and say, well, if the first guy can sell 17 ice creams in an hour, then the second guy can sell 17 ice creams in an hour. And I'm going to say, no, he can't. We're going to start getting what we call the law of diminishing marginal returns with that second worker. And I'm going to say that second worker can actually only produce, let's say 15 additional ice creams. So my total product, which is actually Q, we're going to change this now to total product. Instead of being 17, it's going to be 15 plus 17, or what is that, 20, 32. So we're actually going to sell a total of 32 ice creams by hiring a second worker, not 34 ice creams. And you go, well, why? Okay, well, here's why. Here's how this works, real simple. Let's suppose these two workers walk up and there's a customer sitting at both windows, and both customers just happen to order vanilla ice cream at the same time. Well, the vanilla ice cream is sitting right there. This guy walks over to get the vanilla ice cream, and this guy walks over to get the vanilla ice cream. And they both have to reach in there and dish out the vanilla ice cream at the same time. They can't. They can't both reach into the vanilla ice cream at the same time. So one of them has to wait. And if this happens a couple of times an hour, then you can see the additional production from the second worker is going to be lower than the first worker. And people say, well, what if the second worker always goes first? No. We're just saying that in general, there's going to be less a total ice cream being sold. Maybe they rotate who gets to go into the vanilla ice cream first. I don't know. It doesn't matter. But either way, one of them's waiting. So the additional production from hiring that second worker is less than the additional production for the third worker. I mean, the second worker, right? First worker. So what if we then say, hey, we want to hire a third worker. It's Saturday night and it's really, really busy. We hire a third worker. Well, this third worker is sitting here now. They've got no window to go to, right? And so we really are going to start to see diminishing returns kick in here, because what has to happen is the third worker has to wait for the second worker to step out of the way. Then the third worker steps up to the window to help the next customer. Meanwhile, worker number one has got the ice cream and is now heading back to the window, but has to wait for worker number three here to get out of the way. See how this works? Because there's only two windows for them to work out of, right? And so what's going to happen is that third worker might only add, say, 11 additional ice creams. So our total product then goes up to 43. This is called the law of diminishing marginal returns. And what's going on is we're adding units of a variable resource. And in this case, the variable resource that I'm talking about is the workers, to a fixed resource. And the fixed resource I'm talking about is the ice cream place, right? And as you add a variable resource to a fixed resource, beyond some point, might have, in this case, it was after the first worker, but it might be after the third worker, the fourth worker, the 10th worker, we don't know. But at some point, you're going to get what we call diminishing marginal returns. In other words, the output is going to decline. The additional output is going to decline. It's called the law of diminishing marginal returns, a huge concept in economics. And it's why businesses have to hire the right number of workers, because if you're getting diminishing marginal returns here, to the point, where is it? If you're getting diminished marginal return to the point where that worker isn't even selling enough ice cream to pay for their salary, you've hired too many workers, right? And so businesses have to consider, how many workers do I hire? Is 11 ice creams an hour a good deal for that ice cream parlor? And the question is, we don't know, because we don't know if they're paying that worker. See a little bit later on, and what we're going to do now is I'm going to rewrite these captions across the top. What we're going to do now is I'm going to rewrite these. All right. This, we're actually, instead of saying workers, we're going to say quantity of labor. We're going to call this one total production or total product. How many total there's ice creams they're selling. And this is going to be marginal product, right? And the reason why I'm doing that is because in a little while, we're going to bring in something that we do call W, and W is the same thing as the wage. And so what we have to look at is, how much are we paying each one of these workers? And is there additional production that they bring in? Is this 11 ice cream worth it based on what I'm paying that worker? Now, obviously, there's other expenses too, but right now we're only worried about the workers. Okay, so keep this in mind. It's diminishing marginal returns throughout the rest of this unit and the next unit and then the unit after that. This is always occurring. It's going to come into play here in a little bit. So what we're going to do now is we're going to jump from production to costs, because businesses have to consider their costs. And there are 7 different costs that you need to know. You need to be able to draw all 7 of these, although the first 4 have never been on an FRQ, but they do help you answer multiple choice questions. And you need to be able to calculate all 7 of these. And I'm going to walk you through here and show you how to draw each of them and how to calculate them. Okay, the first is the fixed cost, okay, or what we're going to call total fixed cost. It's exactly what it sounds like. It is the total amount of fixed cost we have. Well, fixed costs are fixed. So let's suppose that we're paying $1,000 a month in rent. Well, if I produce 0 units, how much do I have to pay in rent? Well, I have to pay $1,000 because I have to pay for the rent, even if I'm not producing anything, because it's fixed. What if I produce 1,000,000 units? Say I'm way out here. Say this is 1,000,000 units of something. Maybe this is paper clips. I don't know. Producing 1,000,000 units. What's my rent going to be? Still $1,000. The landlord is going to come to you and say, "Hey, I see that you're selling a whole lot more. I'm going to raise your rent." No, because I have a contract with them for the next year or 2 years or 5 years, however long I sign my contract for. My rent is fixed, and so because of that, if you were to ever have to draw a fixed cost curve, it is literally just a horizontal line at whatever the costs are. Okay. Now, I told you you're going to have to calculate everything here. And we're going to come back to this in a few minutes and how to different ways of calculating fixed cost, but pretty much they would have to give you the fixed cost. Next type of cost is what we call total variable cost, or TVC, total variable cost. This is exactly what it sounds like. It's the total variable cost that you're paying. So this would be like workers. So if I hire 0 workers, what's my total variable cost? Well, my total variable cost would be 0, right? But as I try to produce a greater quantity, so I'm going this way and I'm producing quantity of output. This is quantity of output, not quantity of workers. But to produce a greater quantity of output, I have to hire more workers, right? And that kind of goes back to what we saw here. To increase my total product from 17 to 32, I had to hire a second worker because the first worker could only do 17 an hour. So I needed to hire a second worker to get that additional 15. Well, that second worker is going to cost me money. I've got to pay for them. So what you see is you see this bump of the total variable costs. Now, what this total variable cost curve actually looks like, it looks like a backwards S. And I used to make such a big deal about my class about this and all that, and make sure you can draw it. They have never asked this on an FRQ. I would bet they're not going to ask it this year. But the reason why it's not just a straight line, okay, the reason why it doesn't just do this is because of what the law of diminishing marginal returns. The idea is that first, you're not getting a whole lot out of the workers, and then you start to get more out of the workers, but eventually you get such bad diminishing marginal returns, this guy actually starts to bow upward. Truthfully, if they ask you to draw this on the AP exam, you can draw it as a straight line, just like I did here on the left. But if they ask why it's shaped like it is, the answer is law of diminishing marginal returns. Okay. Next is total cost. Okay, total cost is the same thing. It's your total fixed cost plus your total variable cost. We just add them together. So all we're doing is we're taking this. What's going on here? Okay, sorry, my clicker is not working right. We're taking this curve here, this horizontal total fixed cost, and we're adding this total variable cost to it. So what you get is you just get a curve that is shifted. We get this curve here that's shifted up by the amount of the fixed cost. So fixed costs are 1,000, you'd be right there. So this is the first way of calculating this. I can give you any two of these pieces of information. I can give you total cost, I can give you total fixed cost, and then give you total variable cost. If I give you any two pieces of information, you should be able to calculate the third. So because how do you know? Because total cost is total fixed plus total variable. All right, next. We're getting into a little bit more important here. Those first three total, economists don't think on the total. Economists think on the margin. Okay, so like I say, they're probably not going to ask a ton of questions about total cost, total variable cost, or total fixed cost. But average is an important concept here. And we're going to start off with average fixed cost. Okay, this is another graph you're probably never going to have to draw, but understanding what it is will help you a ton later on when we're dealing with should a firm stay in business or go out of business and that sort of stuff. Okay, so the average fixed cost, get an average, you always divide total divided by quantity. So if I want to know what is my average fixed cost, I take my total cost and divide it by the quantity of output. So if my fixed costs are $1,000 and I sell 1 unit, well, 1,000 divided by 1 is 1,000. If I sell 2 units, well, 1,000 divided by 2 is 500. 3 units, 333. 4 units, 250, right? And what you're going to see is this guy drops and he keeps getting closer and closer and closer to that horizontal axis, but it will never touch that axis, because even if you sell 1 billion units, well, 1,000 divided by 1 billion is still a positive number. You sell a Google units, because Google is a number. You sell a Google units, you still have a positive number. It's going to be really, 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 really close, and we can't draw it like that and that close. So what we do in this class, if you ever had to draw this, which you're probably not going to, is you draw it just like this. Okay, start it high, bow it down, and bring it closer to the axis like that, and label it as AFC for average fixed cost. How do we calculate average fixed cost? Well, we take total fixed cost divided by quantity. What if they don't give you total fixed cost? What if they give you variable cost and total cost? Well, then you would have to be able to calculate your total. They give you total cost and fixed cost. If they give you total cost and fixed cost, then you would have to know that these two added together is your total. Is your total cost. Here we go. Yeah, that's what I want to. Is your total cost. Now we can get average fixed cost. I'm messing this up. Because I'm trying to pull variables in and make it harder for you to think this out. So let me just say, what if they give you fixed costs and variable costs? That's what I'm trying to say. If they give you fixed costs and variable costs, what are you missing? You're missing fixed cost. What if they give you total cost and variable cost? What are you missing? You're missing fixed cost. Well, you know that total cost is fixed cost plus variable cost, right? And you know what your variable cost is, so you've got that one. You know what your total costs are, so you can solve for fixed costs. Once you solve for fixed costs, you now have that, and now you can get your average fixed cost, because I would have given you quantity too. I'm just saying they're going to give you, on the AP exam, every once in a while, they give you pieces of information, and you got to plug two of them to get a third, and then use that third to get an answer. All right, that's all I'm trying to say here. All right, now we're getting into the more important ones. Okay, we're getting into the ones that you will have to draw in this class. Okay, you will have to draw them fairly likely on the actual AP exam. This one is average variable cost. Okay, so we know we already did average fixed cost. And we said average fixed cost starts off high and it gets smaller and smaller and smaller and smaller. Average variable, when you draw it, it looks kind of like a U. It looks kind of like a U like this. Okay, and by the way, notice my axes. Always label your axes. My vertical axis is labeled cost. My horizontal axis is labeled quantity. And then every time you draw a curve, you label that curve. This is my average variable cost. To get average variable cost, you take your total variable cost and divide it by quantity, right? Again, they may not give you total variable cost. They may give you total fixed cost plus and total cost. If they give you total cost and total fixed cost, well, you know that total cost is equal to total fixed cost plus total variable cost. Now we can solve for total variable cost because we have this one and this one. Okay, again, they'll give you two pieces of information and you got to solve for the third. Now that you got total variable cost, you then divide that by quantity to get what the numerical value of this. Okay, and you're getting the numerical value of a single point on this curve. You're not getting the whole curve out of these little malforms. You're getting numerical value of a single point. Like we could tell you that at a quantity of 17, my average variable cost is 50 or whatever. Okay, all right. Why is it shaped like this? Well, it's shaped like this because of the law of diminishing marginal returns. What happens is that as we are, let me go back to the, so this is average variable cost. So the one I need to go back to is the total variable cost curve. We go back to our total variable cost curve, this one here. It's got this shape here. Remember I told you it goes up rapidly and then it starts to level out, but eventually it starts to turn up. Well, when this guy starts to turn up somewhere right in there, that's when your average variable cost starts to go up like this. Okay. So this green dot right here with total variable cost coincides somewhere right in there with my average total cost. If we actually plug this stuff into Excel spreadsheets and actually had a computer graph it for us, you'd find that they actually do look like this, that the ATC curves really do look like this, and the total cost curves and the total variable costs and all these guys, they actually do look like this. Fortunately, in this class, you're not going to have to do much of that plug and chug. They may ask you a math problem where they give you, like I said, variable pieces of information and you have to come up with the third piece. But for the most part, all we're doing is we're trying to draw this guy. Okay, now let's talk about why though. Okay, now I'm getting into the curves that you're going to be drawing in this class. Why? What the heck? What the heck is this telling us? Well, think about it. It's the average variable cost, meaning it's the average cost of hiring that resource or those resources, right? So if we go back to my Pizza Palace example, I said, okay, we got a quantity of labor and we hired one. We had a total product, I don't remember what the numbers were, say 17, and the marginal product was 17. We hired the second worker, we got diminishing marginal returns. He only added 15 more, right? So we were up to 32. And we hired the third worker, I think we added 11. So this is going to be 43. And this may not be the exact numbers I used before, but that's okay. So what's going on here is as I hire more workers, I eventually am getting this diminishing marginal returns. As I'm getting this diminishing marginal returns, my average cost will actually start to rise. The average cost of that third worker, because I'm paying, let's say I'm paying all three of them $10 an hour, right? So it's costing me $30 to hire them for an hour, but notice my total product isn't going up at 17 a piece. It starts going up less. So on average, my costs are starting to rise by hiring those workers. And that's what this line tells us. It's telling on average, how much is it costing me to hire those workers to produce whatever quantity it is that I'm producing here, right? So in this case, I'm producing a quantity of 43. And let's say I'm right here on the curve, then I'm producing 43 workers. And on average, it's costing me X, whatever X is, to hire those three workers. Okay, well, think about this. Why would a business want to know their average costs for their variable workers? Well, because if they're selling the product for lower than the average cost of even paying the workers, they're hiring too many workers, right? If on average it's costing me, um, uh, well, 43 divided by 30, whatever that is. Let's say that's let's say it's 1.7. I don't know what it is. So let's say on average, it's cost me $1.70 for each unit that I'm selling. So for each unit that I'm selling, as I said, 1, 2, and I've gone all the way up to 43 units, it's cost me $1.70 in variable costs. And I'm selling my ice cream for $1.50 a shot. Well, I'm not even paying my variable cost. So I'm wrong. I'm messing up. Maybe I'm trying to produce too much ice cream. I don't know. If I'm selling my ice cream for $3 a shot, then hey, I know that I can bring that $3 in. I say a shot of ice cream, one scoop of ice cream against the world. That's what I'm looking for there. So if I am selling my ice cream for $3 a scoop, and on average it's costing me $1.70 to pay my workers, then I know I've got $1.30 to play with, right? What can I use that $1.30 for? Well, I can use it, that $1.30, I can use it to pay my fixed costs, which, oh, by the way, is right here. This is my average fixed costs, right? And I can also use the rest for my profits. So that's why we learn about average variable cost. What about the next one? This is the big one. This is the most important one. You will draw this many, many times in the next 5 to 6 weeks in this course. This is average total cost. It's total cost divided by quantity. It's the total cost of production divided by the quantity. Again, all sorts of different ways to do it. You can do it as total cost divided by quantity, or you can actually do average fixed plus average variable. If we take this line right here, this average fixed cost curve, and you add it to this average variable cost curve, what you actually get is you get a curve that's shifted up higher. Just, I'm going to jump right to this because students are always confused. They just say, well, what's the difference between this one and this one? They look identical. No, the average variable cost curve is actually going to be down and to the left a little bit. In other words, the minimum of the average total cost curve is going to be like here, and the minimum average variable cost curve is going to be right here. Okay, now let me stop right there before I go any further and warn you. One of the biggest block to understand this stuff when I teach this in my live class, and it's going to be the same thing with you guys. Okay, if I teach in a live class, does that mean you are a dead class? I don't know. Anyways, when I'm teaching an online class, I'm sure you're struggling with the same things. I'm going to be throwing out all these abbreviations. ABC, ATC, AFC, MC. I'm going to be throwing out all these abbreviations. And when I say ATC, if you can't picture the average total cost curve in your head, and if you can't figure out how to calculate it, if I say, hey, calculate ATC, and you're going, oh, the what? The what? I don't know what that is. Then you're going to struggle. Okay. Every year when I teach this in my in-person class, I'm able to spend a day or two practicing this stuff, practicing drawing them, practicing calculating them. We spend time in class playing with these curves. You need to do the same thing. Okay. Or what's going to happen is you're going to get confused about what each of these curves are, and you need to understand what they are, how to draw them, and what they mean. Okay. So let's go back to the average total cost curve. And what does it mean? It is on average, what is the total cost of producing this product? So again, this is really important for a firm to understand this. If I'm an ice cream buyer and I'm selling 43 ice creams on an hour, right? I'm selling 43 ice creams an hour, and on average, it's costing me, well, it was $1.30 for my average variable cost, and my average fixed cost was, let's say, 20 cents, then my average total cost here would be $1.50. So on average, it's costing me $1.50 for each ice cream that I produce. So I have to make sure that my price is greater than $1.50, or I shouldn't be in business, right? Now we're going to find out, can I charge whatever price I want for my ice cream? I can probably charge more than $1.50. I haven't found an ice cream place around that charges less than $1.50. But keep in mind, there's also other variable costs. Okay, other variable costs. I have to buy the ice cream. I have to buy the milk and the all these other things. And then of course I have to pay for the electricity. There's lots and lots of other variable costs. This is just looking at average variable cost of just say labor. If I start adding all those other, then possibly my actual combined average variable cost curve could actually be way up here, right? It could be way up there, but we don't know that. But we're going to right now, just to isolate it, to make it easy, we're going to assume that our only variable cost is labor. And usually when they do a question on the AP exam and for Georgia Virtual School, you always assume only one variable cost. Okay, so you don't have to bring in all these other things into play here. So we have our average total cost curve. All right. Now we're going to introduce the most important curve in all of economics. This is the number one. It's just cool. This curve is super cool. I don't know. It's so cool that the CEO of a major corporation had learned this in his economics class in college. And when he formed his corporation, he decided to use this as his symbol for his company. I give you the marginal cost curve that looks just like a Nike swoosh. It's a neat story, wasn't it, about Nike and the CEO wanting to use this as his symbol? Well, that's actually not true. I made that all up, but I like to mess with my students about that. But it helps you remember it. The marginal cost curve looks like a Nike swoosh. Okay, it is not a check. Okay, please, when you draw these guys, when you draw your marginal cost curve, quantity, cost, it's not a check, and it is also not a fishhook. Okay, it's not the Nike fishhook. It's not the Nike check. It's the Nike swoosh. This thing's got a swoosh here. Okay, now Why is it shaped like this? Well, it's shaped like this because of this thing called the law of diminishing marginal returns. Okay, before I get into that, let's find out why or what it is. Okay, marginal cost, marginal means additional. And what this guy is the additional cost of producing another unit. Okay, two different ways of calculating it. We can do the change in total cost. Delta means change in this course. Okay, delta, the delta symbol is change. It's the change in total cost divided by the change in quantity. In other words, how much more total cost do I have by selling another unit? And what we find is that the additional costs initially go down, but because a law of diminishing marginal returns, it eventually starts to rise. Your additional costs start to rise. Now, diminishing marginal returns actually doesn't start right here at the minimum. It actually starts somewhere else. You don't really need to know that, but just so you know, everyone always thinks that it starts there at the minimum. It doesn't. Okay. By the way, the other way of calculating this thing is change in variable cost over change in quantity. So look at those two formulas, the change in total cost over the change in quantity, or the change in variable cost over change in quantity. And I'm telling you that no matter which one you use, you're going to get the same answer. And you're going, wait a minute, how's that possible? Because is total cost the same thing as variable cost? And the answer is no, it's not. What's the difference between total cost and variable cost? And that's fixed cost. And fixed costs don't change. There is no change in fixed costs. As you go that way, your fixed costs stay the same. So if you do change in total cost over change in quantity or change in variable cost over change in quantity, you get the same answer because fixed costs don't change, right? Said another way, the change in total cost is the same thing as the change in variable cost plus the change in fixed cost, right? And the change in fixed cost is zero. So the change in total cost is equal to change in fixed cost, even though total cost doesn't equal variable cost. There you go. There's that. So this guy is a Nike swoosh. All right. And you're probably thinking, whoopie doo, why is this so important? You're going to find out. You're going to find out. I won't get to it tonight, but I think next week in my live presentation, I'll be telling you, just why this guy is so cool and why economists it's the favorite curve of almost every economist out there. All right. So let's start to go looking at this stuff here. It's the marginal cost curve that determines if a firm wants to produce an additional level of output. In other words, my ice cream parlor here is doing a total product of 43 ice creams. I got to decide, do I want to produce a 44th unit of ice cream? If I'm producing 43 right now, do I want to produce a 44th? And most people would say, well, yeah, businesses are in business to produce as much as they can. Well, I said this last week. Businesses are not in business to maximize their total product, to produce as much as they can produce. Businesses are not in business to produce at the lowest cost. Businesses are not in business to maximize total revenue. Okay, this is total revenue is money coming in the cash register. Businesses are not in business to produce the most product they can produce. Businesses are in business to maximize their profits. It's all about profits. And so profits take into account total revenue minus total cost is what gives you your economic profit. If you go back to what we did at the very beginning in this class today, when we were doing economic profits here, I said that you got to take into account your total revenue, take out all your costs, including your opportunity costs, to figure out what your economic profit is. And this is what businesses are shooting for. They're trying to maximize that that economic profit. And the idea here is therefore you got to take into account these costs. So a business may choose not to produce the next unit. The business may look at this and say, it's not worth producing a 44th unit. Why? Because my marginal costs are starting to rise. Okay, I'm right here. And if this is 43 units, if I want to go to the 44th unit, notice my marginal cost curve is going up. And if my additional costs are going up, that means my profits could be actually going down, right? I can actually get to the point where I'm maximizing profits by stopping right here at 43 units. And no, I'm not, I don't care if there's customers beating in the door saying I want more, because the only way I can serve more than 43 ice creams in an hour is by hiring another worker. And I don't want to pay for another worker, because if I do that, my profits go down. Okay. And so this is where this marginal cost curve comes into play. Businesses need to understand what their marginal costs are. Okay. So what we're going to do now is we'll put these three together. And this is, again, a curve that you're going to be, or three sets of curves you're going to be drawing a whole lot here. When I draw these, okay, most of the time you're going to draw ATC, average sold cost, and marginal cost. Every once in a while, you're going to have to draw the average variable cost. I draw these guys here. I do quantity in the horizontal axes, cost in the vertical axes. I then draw my average sold cost curve. My average sold cost curve is a kind of a U-ish shaped thing. All right. When I draw my average variable cost curve, the average variable cost curve is going to be down. The minimum is down and to the left of the average sold cost curve. That's a mathematical surety. If you don't draw it that way, you would lose the points on the AP exam if this was the case. The other mathematical surety that I am telling you right now, 100%, it will be a point on the AP exam. It will be a point on one of your test questions and probably several of your, in fact, not probably, and definitely several of your assignments in this class. It's going to be points. If you don't draw what I'm about to show you the way it has to be drawn, you will lose points and you will not do as well in the AP exam, because it is a mathematical surety. If you're not drawing it this way, then you're violating a law of math. And that is that when you draw your marginal cost curve, the marginal cost curve has to go through the minimum of these two curves. So you have to practice this. This is one of the few things in this class where your artwork is actually being graded. All right. If I am in a hurry and I do this, and I draw my ATC like this, and I throw my marginal cost curve in like that, you're going to lose points, because that's not the minimum. The minimum is right there. And you go, oh my goodness, that's picky. Yes, it is, because you're violating a mathematical surety if you don't, so you don't run it to the minimum. So what I always do when I'm doing this is I always do this. I draw my quantity, I draw my cost, I draw my ATC, and then I take a second and I stop and I look at this guy and I say, where's the minimum? Minimum looks like it's about right there. Now I draw my marginal cost through that minimum. If you'll do that, you'll get these points. If you don't, you're going to lose the points. Now, why? Why is this a mathematical surety? Okay, here's the best way to explain why the marginal cost always intersects the minimums of the average. Okay, marginal cost always intersects the minimum. I always use students' test scores and their average in the class. So if you have an average in here right now of a 90, that's your average. And on your next test, or your marginal test, your marginal test, in other words, your next test is an 85. What happens to your average? Your average definitely goes down. What if instead on your next test, your marginal test, you get a 95? What happens to your average? Your average goes up. So anytime marginal is less than average, average is going down. Anytime marginal is greater than average, average is going up. And that's all we're showing here. Anytime that marginal, let me just do it with one here. Do I have one? There's one I draw. I don't know if I drew one, just one. Let's try it. It's the problem with erasing things. So quantity, cost, draw your ATC, stop for a second, look at it, find your minimum. Looks like my minimum is about right there. And then I draw my marginal cost. And by the way, what if I drew this and I did there and I drew it that way? That's probably close enough. Okay. And if you do that and you go, oh crap, that's not really the minimum, then just do this to make it a little bit bigger so it is the minimum. Okay. Now I'm telling you on the AP exam, I see this all the time. that's acceptable. If you do like that, no, that's not acceptable. Okay, but just make your minimum. If you look back and you go, oh crap, I'm not quite at the minimum. I'm a little bit to the left because really the minimum is right here. Then you can fix it by just making that a little bit bigger, right? And you're good. Now it actually looks like it is to the minimum, right? So anyways, so what I'm telling you here is as long as marginal is below, wrong color, as long as marginal is below average, then average has to be coming down. See, as I go this way, marginal is less, average is going to be coming down. And then as soon as marginal goes above average, then average starts to go up. And because of that, marginal cost has to intersect the minimum of the average total cost, and the same thing with average variable cost. All right, I think I beat that to death. I always do when I teach this because students mess this up and they lose points and they're like, why did I lose these points? But it's got to be the case. It has got to intersect the minimums of the average variable cost and the minimum of the average total cost. So what I'm going to do is I want you to take a few minutes to fill this in. You'll pause your video right now, and I want you to go ahead and see if you can calculate average fixed cost here, 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 and all these blanks. Okay, your average variable, total, average variable. Okay, see if you can calculate all these guys. And then what I'm going to do next is I'm going to then show you to be one of the multiple choice questions on the AP exam. Pretty much every year that I've seen a released exam where they release all the multiple choice questions, one of the multiple choice questions is they give you a scenario, they give you two variables, and you got to calculate a third. So they might give you two things and you got to calculate that. Or they might give you two things and they got to calculate that. Now they got to give you the right two things. I mean, we can't get average fixed cost from total cost and well, actually, we could. But anyways, there's different ways of doing all this stuff. But there's two ways of calculating all these things across the top. So go ahead and pause the video, and I'm going to give you the answers in about 10 seconds. 9, 8, pause and fix this. 3, 2, 1. Okay, let me give you the answers here. You started your video down. You filled these in. Let me show you the answers. There's your answers. Okay. All right. So some of these are easier to get than others. So let's walk through. Let me walk through each of these and show you how to calculate each of these. Okay. So average fixed cost, okay, the easiest way to get average fixed cost is to take fixed cost divided by quantity. So in this case, here's your quantity, right? To get this one, well, I knew right here that my average fixed cost was 33.33 times when I produced 3 units. So how about if I did 33 is equal to x divided by 3. Solve for x, we find out that x is 100. What is x? X is fixed cost. So this number, that tells me my fixed cost right here is 100. And since it's 100, that means for 1 unit, my average is going to be 100. And by the way, we can now go ahead and fill in every one of these. Okay. We could have also done 33.33 times 3 to get the 100. And I know you're like, that's 99.9999999. They're not going to make you do one where you have continuation like that. But that's what I did in this class to trick my students, because that's what I like to do, is trick my students. But anyway, so you see how we got all this. And now that we've got all this, we can now get all of this. So this is covered and this is covered. Okay, let's go to average variable. Well, how do we calculate average variable? Average variable cost is total variable cost divided by quantity. Now this one varies, so we can't just get one number and be done, right? But we can definitely come right here, okay? Take total variable, 240 divided by 3 is 80. So now that one's done, right? And they can do that different ways. The other way we could have gotten this, okay, we also could have gotten this one here by knowing that average, we could have done that average total cost is average variable cost plus average fixed cost. And for this quantity right here, we have the average total, which is 113.333. And we have the average fixed right here, which is 33.33. And we could have then solved for average variable cost, and we would have found out that it's 80. See how there's two different ways of getting this answer right here? All right. What about the next one? And by the way, if you've got all these and you know how to do them, I know you're probably a little bit bored. You can fast forward till I get past this chart. As soon as you see me go there, you know that it's time to move on. And I've got 9 minutes left, so I may not get there minutes. Maybe I'll get to tonight. Okay, so next is average total cost. Well, I just did average total cost. I just calculated this here. Average total cost. Well, no, I didn't. I did average. I did total variable cost. Okay. No, I didn't. I've done average variable cost. Okay, total variable cost. All right, total variable cost. We know that total variable. Well, we know that total cost is total fixed cost plus total variable cost. So we can do any kind of permeation to get to solve for this. This is where you do your math, your algebra. What I call math voodoo. You do your math voodoo to solve for total variable cost, right? Well, I gave you total cost over here. Actually, didn't give you any of those, but we could figure that out starting right there. And I also gave you, there's total cost and total fixed is, oh, it's right here. It's 100. So you know this. So you know this one here is always 100, right? And then we're just going to add total variable to get total cost. Okay, so let's look at a couple to see if this actually works. What I just told you, if that the formula I just gave you will work. It may not. We may have to figure out another way to do it. Okay, so the first one I need to find this guy right here. Well, I knew out here that this was there, so that's 100. Okay, and I'm solving for this. Do I have my total cost? Total cost. Okay, I did not. I did not have the total cost there, so I can't get that. But what I can do is I can solve for that real quick. Okay, this one's easy to solve for because I gave you marginal cost. And I don't know if you remember earlier when we did marginal utility, but to get total, total is always sum of the margins. So let me show you this real quick, okay? Start off with a total cost of 100 when I'm producing 0 units because you have those things called fixed cost. When I go to produce the first unit, it's going to cost me an additional $90 to produce that first unit. So total is now sum of the margins. So it's the 100 plus the 90 gives you 190. What about when I go to the second unit? Total is sum of the margins. 100 plus 90 plus 80 gives you 270. And so I can now fill in each of these guys right here to get my total cost because I gave you all the marginal costs. And so if you know that total is always sum of the margins, then you can always calculate your totals. Okay. At the same time, what if I didn't give you this number right here, but I did give you this 340? Can you solve for this number right here? Sure. Total is sum of the margins. So you'd have to go 100 plus 90 plus 80 plus what? X gives you the 340. So you solve for X. Okay, you know that they're equal. You know that 100 plus 90 plus 80 plus whatever number this is equal to 340. And when you do it, you find out it's 70. So you can also go, you also solve for marginal when I give you total. Okay, and by the way, some of you guys may have to stop, pause, and rewind when I'm teaching you this. When I'm teaching this in class, students will stop and say, wait, say that again, or whatever. You can't do that. So stop, pause, and rewind. I can say the exact same thing 100 times for you, right? If you stop, pause, and rewind 100 times. That's the nice thing about online. All right. So having said that, we can now calculate everything up, our average variable, our total variable, right? Because we have total costs. So all of our total stuff we can do because we can calculate total cost based on this, and we know what our total fixed costs are. Since we have this and this, then total variable cost is real easy to do. All right. What about average total cost? Well, average total cost is easy to do because once you calculate your total cost here using your marginals, so you're using all your marginals to get your totals. You're adding up all your marginals. 100 plus 90 plus 80 plus 70 plus 60 is 400. You do the math, that it will be equal to 400. Now I have my total cost. So how do I get my average total cost? Just take the 400 divided by 4, which is 100. Right? So you can calculate anything on this line now because you now know your total cost. And then last but not least, well, I guess we already did total fixed cost, and that's the chart. All right. Strongly suggest that you go back and now that I've gone over it, any of these that you didn't get, go back and rework them. Because I'm telling you guys on the AP exam, they're going to give you two pieces of information and you're going to have to calculate the third. There will be a multiple choice question for sure on the AP exam over this. There has been every year. So be prepared for that. All right. I'm going to stop right here. This is a good place to stop. I've graphed all the curves for you. And what I'm going to do next week is I'm going to finish this up. There's actually not that much left. There's probably 10 more slides. And then I'm going to parlay this into the cost curves into the start of perfect competition, which is actually the next unit. So I'm going to stop here mainly because I don't want to get too far ahead of you guys. And I think your brain's probably dead after all that math. I know mine is. And I hope you guys have a great evening. And I will see you later. Let me know if you have any questions. And I'm going to actually sit here for 3 more minutes just in case somebody does pop on. But I'm done teaching for the evening. So adios, amigos. Ooh, I can make faces at you for the rest of the evening. I'm not going to do that. I'm going to pause it.